I'm repeating myself a little bit here, but recording time cuts out. So if we look at these four equations, starting from the simplest hydrocarbon you work with, hydrogen, methane, propane, then butane. These are the two that are really important in your world. Methane or natural gas and propane are used everywhere. The reason we want to balance the equations is because of the wildly differing amount of oxygen going here, right? If you start moving your way up the hydrocarbon list and you don't change the oxygen intake, you're going to get incomplete combustion and die. And I think that's an important enough reason to balance the equation. Yeah, conservation of matter and energy. Matter can't be created or destroyed, yada, 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 yada. Unless you're the Hulk and, he technically can't work unless he's like a puffer fish, because otherwise, where's he getting the matter from? But he's definitely an unbalanced equation. So let's look at your home barbecue. Most of you, your barbecue is on propane. Some of you have a barbecue on methane. How can you tell the difference? If it's on methane, it's usually attached to the house itself. Let's suppose you're going to convert your barbecue from natural gas to propane, though in actual reality, it's usually the other way. But a propane to natural gas conversion can be done on your barbecue, your hot water tank, and your furnace. But it has to be done correctly, because the first thing we noticed is to balance the two equations, methane needs 2 scoops of oxygen, propane needs 5. That means propane needs 2.5 times the oxygen that methane does. Now, really, the way we adjust it is we would have to cut the fuel. Your Bunsen burner would allow you to add 2.5 times more air by unscrewing the chimney, but you don't have an air adjustable intake on most barbecues, and certainly not on a hot water tank or a furnace. The only thing you can adjust is the fuel. So if you can't increase the oxygen 2.5 times, you can cut the fuel flow by 2.5 times. And this is how it's done. These are gas orifices, and you can stop snickering. It's not funny. One of these is for methane. One of these is for propane. Can you take a guess as to which one of these orifices is designed for propane? Well, if we burn methane and we switch to propane, we have to cut it down by a factor of 2.5. So that's the methane orifice, and that is the shrunken propane orifice. And is it 2.5 times? Well, let's see. I just screen capped this off the internet, and I took a little quick measurement. I blew it up enormously. So there's no way it's 41 millimeters across. Those orifices are tiny. But on screen, I got 41 millimeters and 62 millimeters. If we're taking the area comparison, area is what's important, not the diameter. You increase the size of a hole, the flow is across the whole face of the hole. It's an area measurement. And it doesn't matter if it's square or circular if we're just comparing the two as a ratio. So it works out to this. If I do length times width on this side, and I do length times width on this side, in other words, square it, and I divide, visually, just using a screen cap, I got a ratio of 2.25. So seriously, I literally could make an error of a pixel. So there she is, bang on. The gas orifice is 2.5 times larger in area, just using Weber's website and getting that. So our equation is working beautifully. They literally have a hole that is drilled, not 2.5 times wider, 2.5 times in area. If you don't understand what the area has to do with the flow, squeeze your toothpaste at home and think of how much is coming out. It's the area times the length of the tube of toothpaste coming out. So there it is. This equation is supported in the reality of the situation. So any gas fitter will have a series of these orifices, typically methane and propane, though I'm certain you could get a butane orifice if you look, though I've never heard of anyone having butane cylinders bigger than just like a Coca-Cola bottle. I've never heard of delivered butane supplies. So there you go. That's balancing the equations and for combustion and what they mean in your regular world. What would I expect you to do on a test? I would really like it if you could do methane and propane, this slide here, and explain the difference in that fuel orifice. That would be my dream, to leave you with that, leaving the course, because failure to change these orifices correctly, it kills people. If you go ahead and switch to propane from methane and you didn't change the orifice size, you're not adding enough oxygen, and out comes the carbon monoxide and people die. And it's easily avoided. And that's why you need a license to gas fit. And then we'll move on to other topics next.